Now I'm going to move back and forth a little bit.
Доклад будет про среднекопытное животное. У нас просто кошка с копытами.
And we are going to talk about the
Можно начинать, да?
hooved animal.
Собственно, меня зовут Дмитрий Лахович.
I am Dmitry Lachvich. I will talk about the Cat's House data platform. Everyone has a data platform, or otherwise you can use somebody else's. Anyways, I will tell you about how we built the data platform in our company, the Square Meter, and why this is important for us, and why we are driving this, and why this is good for us, and how can we live in the world where data rules the world, and this data is easy to use. The Square Meter company is about prop tech. If you do anything with a property, you come to us. Every fifth new development is sold through us. We also work with land plots and secondary properties, and we will help you come to us. And we are a medium-sized company, and we have in our databases dozens of terabytes of data. So we have middle data, and the clicker is not there yet. And we have terabytes of data, and this defines the stack that you're working with. Because if we had more data, probably what I'm talking about wouldn't be useful. We are working with JSON, and they are JSON-like systems that come to us from microservices. Our main customers are analysts, but pretty often it is also about a partner coming to us and asking for analytics, and we tackle that. We live in Yandex Cloud. We are cloud-based, which defines the stack we are using, and we have certain prerequisites that we can reuse, and we use data in a cloud, and we also have migration plans for the company. And for the past 6 years, we have had the data storage, which could show the data about who, what, and how much we sold. And this worked on SQL. We also had self-written tooling and IBM code and NiFi and Airflow as ETL. Then we understood this is hard to support, hard to scale, and to a certain extent the development stopped. And what happens at a time like that? You can develop this and use a lot of resources. But when we understood that this cannot be tackled with more resources, we have to undertake certain steps. And then sweet words like migration, new platform, things like that come over. You have something old, something new, and you want to move to something new. You start building something new, but the old is still operational, and you do migration. And we are the sort of people who wanted to live in a house where we would feel comfortable and to have more data and to do more and we don't have any choice, because we live in Russia, and for us, we have our own journey and track. We cannot really use the Western AWC-like cloud providers, so we don't have a lot of choice.
Нам не подходит слово внедрение. Нам надо
And
сразу же
we
забыть.
are not a very
У
big
нас
company.
три варианта есть сейчас, которые
So
существуют. Это
implementation
взять условно
is
гринплан,
not good for us.
у
We
которого, к
need the
сожалению,
plug and
сейчас
play.
немножко проблемы с open
So
source
the
версией.
choice
Тоже
is
ничего не
small.
доказано.
We have the green
И есть
plum.
некоторые разделения
The
комьюнити. То есть
OSS version
нужно еще и
is
выбрать
dead.
между гринпланами. При этом нужно
People
сразу
say
DBA
different
и
things.
сразу
You have
нужно
to choose
понимать, что там
between green plum.
специфичное железо.
We
Ну, в
also
общем,
will
дороговато
need the
получается.
DBA
Можно
and
взять
very
ClickHouse, который
specific
у нас уже, в
hardware.
принципе, есть на
We
старом
could also
хранилище. И
use
многие берут,
ClickHouse.
в
We
принципе,
already
и
have it with the old
строят на нем
storage,
хранилище.
and
Но у
a
нас
lot of people
вводные такие,
are
что так как мы в
taking it
проптехе, у
to
нас
build
достаточно сложная
their
модель,
data
у нас много
warehouse.
джойнов,
Since
у
we are
нас
in a
достаточно
prop
прям все
tech,
это
we
развесисто.
have
И
a lot of
сложно, на самом деле, по
joints,
опыту
and
скажу, построить такую
it
систему на
is
ClickHouse
hard to
без,
build
опять же,
the
DBA.
system
И
on a
также,
click
собственно,
house
ClickHouse у нас
without
это
the
история базы
DBA,
данных для инженеров.
and
То есть на нем можно
this
строить
is
замечательные продукты,
about
но при этом нужно понимать, как он работает внутри
engineers. You
и
can
что и
build
как. Простого
excellent
пользователя, если вы туда запустите, скорее всего,
tools for
вам базу
engineers,
оставит.
and
И мы
an
пошли в модное слово
ordinary
Lakehouse, оно уже
user will
бороздит
get completely
просторы
lost.
России
And
глубокие,
now
которую
there is another
тоже
system
вирусилась
which has
с
been
помощью
around
компании
in
DataOps.
Russia
И,
over
ну,
the past
собственно, история
4 years.
такая, что
It
нам нужен открытый
became
формат
viral
какой-то,
with
который мы можем
Databricks.
использовать с
We
разными
need an
движками, такими
open
как Trino,
format
Spark,
that
Flink,
we could use
ClickHouse или
with
даже GreenPlum.
different
Нам нужен
tools such
разделить
as
compute storage,
GreenPlum,
потому
and
что мы хотим не
we
разориться и
also
хотим
need
использовать
to
такое в
separate
облаке.
the
Опять же,
computer
нам
storages,
постоянно держать
since
нагрузку не
again
нужно. У
we
нас
are
нагрузка,
in
собственно,
the
она, мы очень
cloud.
посчитали,
We are
сидим, уже как-то
flexible,
вяло
and
отдаем KPI.
so we
Собственно, и
calculate
строим нашу
everything
форму
during the night,
шлепа. Это
and
наша платформа данных.
we
Собственно,
are
Lakehouse —
building
это
our
просто
own
необъятные табличные форматы. То есть
database,
есть,
and the
ну,
Lakehouse is about
знаете,
the
форматы там паркет,
modern
орг, авро. Это
open
все форматы хранения.
spreadsheet formats,
Это все про
and
то, что,
you
ну, вот
know
как оно на
a
диске
lot
лежит.
of others,
Но эти
and
форматы сами по
that's
себе
how you can
хранения не дают вам
use it.
удобства,
But
как будто бы с базой
these
данных работать.
formats
Поэтому
themselves,
вы,
these
собственно,
formats do not
сами
provide
изобретали, там лет
to
5-10 назад
you
люди сами
the
изобретали
convenience.
фактически какой-то
It's
велосипед,
similar
как
to what
сделать
we
так,
did
чтобы это
5 years
больше
ago
было
when
похоже на,
everyone reinvented their
скажем так,
own
на
wheel,
таблицу, на базу данных.
trying to
Как это
make
сделать
sure
так, чтобы
that it
можно было
looks
делать
more like a
апдейты,
database
инсерты нормально, как
with
сделать
the
делиты и так далее.
updates,
Все про это
inserts,
все решает,
deletes,
собственно,
etc.
Lakehouse
All of
форматы.
this is
Какие нам, собственно,
addressed
нужны
through
были
the
истории
Lakehouse
с
formats.
Lakehouse
And
форматами?
what
Нам нужны были атомарные
stories did we need with the
транзакции, то есть все это будет
Lakehouse
мердж
formats? We
происходит таким
needed
образом, что либо
atomic
выполняется, либо не
transactions,
выполняется. Вы не
and
видите
data search is
результатов
either done or
промежуточных
is
каких-то.
not
То есть
done. You
если
don't
что-то
see
произошло не
interim
так, вы
results.
не
If
увидите, ну,
something
ерунду,
goes wrong, you will
полузаписанные
not
данные.
see
Второе, нам нужны согласованные обновления, и нам нужны
rubbish
масштабируемость самих данных и
data.
метаданных.
We
Потому что
also
сегодня
need
10
the
терабайт, завтра 100
aligned
терабайт. Мы
updates
хотим
and
уметь вовремя отвечать
scalability
на
of the
запросы
data.
бизнеса на расширение
We
данных.
should be able
Собственно,
to
а какие
respond
есть
fast
сейчас
to the
Lakehouse
business
форматы?
needs.
Их по
And
факту три,
what
если
are
кто-то
the
знает четвертый,
available
пятый, приходите.
Lakehouse formats?
Я вот
If
с радостью
somebody
послушаю,
knows
но по факту их существует
formats
три штуки.
4
Есть
and
худи,
5,
есть
but
Data Lake,
what we
Iceberg.
see are just three.
Собственно, худи классный,
Hoodie, Data
крутой,
Lake, and
много
Iceberg.
фич.
Hoodie is
Прям
cool,
вот это все
nice, with
здорово,
a
но
lot
не
of
работает.
features.
Вам прям
It's
нужно
all cool,
погружаться
but
в
it doesn't
историю
really
того,
work.
как же оно
You
устроено
have
внутри.
to
Очень
dive
много ручек,
into how
которые вы
it
можете
works.
покрутить и сломать.
And
Очень
there
много
are a lot
тулинга,
of
который
handles
вроде как
that
обещает
you
вам
can try
много-много-много
and
всего, но
break.
опять же не
And
работает.
there are a
Формат
lot of
хороший, у него
tools,
даже
but
может быть
it
больше
is a
всех фич,
nice
но
format,
надо
and
сильно
they have
погружаться и, в принципе, идти
the
к
most features,
разработчикам и
but
спрашивать, как
you
же
have
сделать
to
так, чтобы
really
он
dive
работал.
in, and
Второе.
you have to go to the
Data Lake
developers and
тоже
ask
классный,
how to make
крутой,
sure that it works. The
но
data lake
проблема —
is
это
also cool and
Databricks
nice,
first формат.
but it
Это
is
формат жил,
overcomplicated.
к сожалению,
This
достаточно
is
долго в экосистеме
data
Databricks,
first
причем жил
bricks
в парадигме того, что
format,
если ты не
and
используешь
for a
платную
long
версию, скорее
time
всего, у тебя
they
фич нет.
said if you are
Это первое.
not
Сейчас они вроде
using
как повернулись
the
к
pay
комьюнити,
for
берцом,
version,
сказали
there are no
побольше open
features.
source
Now
и
they
так
turn
далее.
their
Но по
face
факту
to the
это до сих
community. They're saying we are more open source, but anyways, this is more Databricks first format. And then there is also Iceberg, and it works right out of the box. And Iceberg was the easiest to work with, so you just plug and play. And we wanted positional deletes. For example, when you have some download to the third party, and you understand that with the third party, you understood that you have to do another download, but with somewhat changed numbers, because that's what they're asking for. And you can do a simple update and download again without rewriting the files. It's all working fine. We have selected Iceberg, and Iceberg, just as any other spreadsheet format, it has a certain structure and the types that it supports. It supports a lot of primitive types, and in the third version there are complicated things like geometry, geography, and the unknowns, and there is a complicated thing similar to a camera, but it works well in a binary format. And everything that you need to organize the hierarchy, that would be hard to organize in a 10-year-old database, is available there, and the format supports the evolution, and you can change the format of columns and the sequence. And if there is a client with a legacy format, they can still use it. The format itself is onion-like, so it uses I'm losing the voice. It is using Parquet and Abra in data files. There are three layers. There is a catalog, then a metadata layer. All the layers are important, but that's how the world works. It will not work if it's not in sync. We have data files, manifest lists, and manifest files. And in the data layer, we keep everything that we are recording and what we are deleting. And the format on the disk or the file system uses the following paradigm. You are writing the files, then you have the manifest and data files, and it grows for some time, and then you do maintenance, and you clean, the system cleans up itself what it doesn't need right now. The main idea that is responsible for metadata catalog is the manifest file, and it has a list of files that is used for keeping the data, or it contains the list of deletes that we will do. So if you have ever reinvented the wheel with Parquet or org, they use exactly this logic. And Iceberg supports exactly that. And you can change the fields, move them up, etc. You need it because if you have a spreadsheet, which is important for the business, you can evolve it, and the old clients will not be deleted, they will be supported. So you can keep the spreadsheet that supports the whole business. You can keep it as a core, you can update it, and you can also see what it looked like historically and what happens. And So first, we identify the transaction strategy, and we have the org bucket and Terra, and then we check if everything is fine. We check the uniqueness, and we make sure that everything is fine. And we might have certain limitations in Iceberg. We create new manifests and new snapshots, and it is the state of a spreadsheet at some point in time. And then after that, we do the following. We take the metadata that we replace, and then we make a recording. If when you made an entry, somebody else was making an entry, another client will check whether the number of snapshots increased in the time that they were writing, and if it increased, they see that somebody wrote in this table. So Iceberg supports the optimistic occurrence for most cases. For the storage, it's all good.
Okay, so we upload the snapshots. There can be lots of snapshots. Some catalogs allow you to give a general picture of all the snapshots. So we check the scheme, we read the manifest list. There's lots of statistics. It understands which manifests it needs, which it can skip. So we filter and then upload the manifest files. The manifest files also has lots of statistics that we can take, right? And then we have to use some filters. Employing these filters, so we get the data files only which we need, we decode them, and then we provide it to the client. Okay, so Iceberg catalogs. Iceberg catalogs optimize productivity, they coordinate operations. Iceberg works well with C3. If you lose Parquet, it's different. The operation can take a lot of time. Okay, so with Parquet tables, it will work much longer. It also provides the access to the tables by names, table name. So this is the function which is responsible for authorization as well. Which kind of catalogs does Iceberg have? Well, basically there is a set of 6 types: Hadoop, Hive, JDBC, REST, and Nestle. Okay, so you can write your own catalog. It can operate on its own protocols for your clients. You just have to understand that there are many of them. They all have pros and cons, and sometimes there are more cons than pros. So how does one choose a catalog? Well, this is what is happening right now. This is some kind of a gold rush, right, about the formats. There are a lot of mergers and acquisitions of companies who are doing that. So Databricks bought Tabular, and Databricks sort of is in the lake. A lot of providers like Amazon, for instance, have everything. Okay, so if you work with Amazon, you can use their catalog. If you have your own vendor, you can use your own vendor. If you migrate from the hard drives, you probably already have Hive. Take Hive and forget about it. Again, if you have a lot of time and your engineering team doesn't have a lot on their plate, take Nessie and you can basically pump it up. Okay, so which problems does Lakehouse have? As any other database, it has quite a few problems. We already dealt with these problems, so we are ready for them, right? So you don't have to go to vendor if you know the problems. It's live format, so not all drives support everything. So the practice shows that if you use one drive, everything works well. If you're using 2 drives, some statistics could be lost, some other things could happen. Second, the specification. Specification appears, and then disappears, and what happens with it, we don't know when everything is finally implemented. Okay, we're also striving towards better catalog, but since we need maintenance all the time, and you will be doing maintenance, I assume that you will be fixing your bugs quicker, and then you will have new features appearing. By and large, every day, day by day, Iceberg is becoming better and better. New functions appear all the time. It is not a black box, unlike database, so you can take it and see what happened there. This is priceless, because if you have a black box, you can't get into it and you can't understand what was happening. All right, so now that you've chosen a format, what's next? Then we decided to build a data platform as shown in the picture. So we've got everything except for the blocks colored in yellow. But basically, what do we have? We have Trino. We use Trino, and the previous speaker already told you about Trino. Our goal was to make it in such a way that people who are working with this platform could utilize it quickly, efficiently, and release their products quickly. We also want the job to be interesting. We also use the stack. We have Airflow, dbt, and everything is covered up by Cosmos in our case, okay? So Flopa m2.ru is Trino. Okay, we also have terabytes, not petabytes of data. Again, ours is not a very big company, so we use it both as ETL and as everything else. So basically, our superset looks at Trino, and it can display the dashboards and everything else. It works well. We don't have any requirements for super quick processing. So what do? We upgrade Trino. It lives in Yandex Cloud in Kubernetes. We use the Trino's elasticity, that is to say, we engage workers when we need them, and when we don't need them, we don't engage them, and we don't have to pay. So this all happens through the OAuth to providers, since we don't have to manage logins, authentication, and things like that. Do you know what Airflow is? Okay, it's cron. What is cron? So basically, when you launch the task according to a schedule, this is a standardized function. You can look it up on the web. Some people may disagree, but maybe those who disagree know more about it than I do. DBT, okay. I think you all heard about DBT. What is it? Well, again, there wasn't much time. A lot of conferences are happening right now. But basically, you are giving your data engineers and system analysts a certain structure of the repository, which has a SQL code, and which you can templatize. So SQL code gives you a super graph of calculations. You don't have to do it manually. So DBT is doing all that and a lot on top of that, such as free reporting. So you can all store it in one place, and we do use that. And we'll tell you why this is important to us. Okay, so we have DBT, we have Cosmos, we have Airflow. So this is all everyday routine for a data engineer. It's not that interesting. It was interesting in 2019. Now this is routine. Anybody can do that. There are lots of courses which teach you to do that. So we use our own Trino connector. We have Trino plugins for Airflow DBT. It's called Cosmos. What does it do? It takes a DBT model or models and builds you a tree of DUGs that could be launched according to schedule. So it's not just one task that launches the DBT model. No, there is the whole tree okay, the whole lineage that you can launch. And since the launch of DBT is parameterized, you can launch the same model in different environments, given in mind different drives. So you can basically, by giving a command to or rather by working around it in SQL, you have the result on the screen. So a data engineer in the morning comes, presses the clear button, it all recalculates, reanalyzes, works well. A few words about ingest. The Mongo database is the most commonly used source. So we basically bring it to our Hadoop. Then we do the dump, and there it goes. It works for a while. We have about 100 different collections every day, about 2 terabytes probably. So we store that on the hard up. We have Postgre SCL, and we write on the DBT. We add Postgre to Trino. We describe a model that allows Trino to take it and utilize it, and we can use the resources and take it all out. So basically, once every 24 hours, we download everything that we have on the service. Then we have the CDC, Kafka, and other sources. But this is the major resource that we use. This was the first task that we decided to solve. Okay. So what's the most problematic thing? The JSON. JSON is a semi-structured format. We take Mongo, JSON, it has to be sparsed out. So we'll bring it up to some kind of a decent look, and we do all of this with SQL. We have to write this SQL ourselves, quite a lot. Nothing to do, but we generate it quite easily. Some things will not be generated automatically. You will have to put in some manual lines, but it's okay. At the same time, you have to understand that DBT will not always generate you a table. So you will see whether it is materializing on the disk or not. Now, the platform was launched in November. By now, we've had 700 models. These are all models that business uses. What kind of layers do we have? We went into the architecture. I'm sorry, my presentation is about a bit of everything. So let's talk about the different layers and how we separated those. We have the bronze, copper. Bronze is for raw data, copper. Again, because we have to take care of JSON, so that would be clearing up or joining other stuff. So this is kind of the first more or less lookable layer. So it's copper and then silver. The system analysts are responsible for the silver layer. They are writing the code for consumption. And then we have the golden layer. The golden layer has the contract for the business. Okay, so once we've made it, once we've created it, we cannot change it if we want it. No, this is a contractual stuff that we have to support. So such layer separation allows you deliver the value. Each of the participants know his area of responsibility, and we can guarantee a specific quality for each layer.
Мы живем в монорепе, у нас все покрыто CI.
We live in monorep,
CI-тесты для DBT.
And from there we launch the tests on the DBT. The DBT allows you to test your data. How is this to be done? We launch CI/CD tests. For instance, when we create a new branch,
есть некоторый sample, то есть мы
we have a sample for each source.
новый источник и сразу
So the situation is typical. There is a new source. So once we start working on it, it basically generates automatically just 1% of data on the source. So a developer does something, pushes it in this branch, and it starts CI. The CI schemes are brought over for gold, silver, copper. So there is a branch name, let's say silver. So what we do is basically we get rid of the headache about merging something that doesn't work. I think about 95% of cases of our mistakes are taken care of CI level. Okay, so basically 5 steps to success. How is this done in the company? How do we deliver value from the point of view of business? We have a business idea, and then it goes into the number 5, into the reporting, regular reporting. But let's talk about points 3, 4, and 5. The kind of every 24 hours. In data flows, we use jobs which take data from the sources. Then there are other jobs that take it from the CDC of Kafka, but let's talk about T-1 analytics. After each ingest, we have a data sample on each source. It takes quite a lot of time, because basically we have to archivize everything. We have to take into account all data, not just the first 300,000 lines. And then the Airflow launches DAGs, which gives you DBT model. So all this Trino 700 model that I mentioned is being run, and is building a model. At the same time, each model is a task in Airflow, and we can launch them task by task. Okay, so once this is built, once the regular reporting is done, you can look at it through Trino, you can look at it through DBT, documentation, then your workday starts. So the system analyst starts his morning with building up a new table. He may go to the customer, to the backend, and get info from them. But what does he do? At the end of the day, he writes an SQL code, he checks his hypothesis, he understands what he needs, and he builds a new model. So on his local notebook, he writes this model out, and he should launch this model right away and get the result in his own private space. So he doesn't have to go to a data engineer for help to get the result. He just launches an instruction or a command, authorizes himself when the prompt comes up, and the Trino cluster calculates his model, which happens rather quickly. Why does it happen quickly? Well, the DBT can monitor changes in the models that have been done recently with the defer mechanism. We have the defer master, and when the system analyst uses the local hardware, it's being detected. Okay, and he can also look up what's already there. All right, so he built it, he gave it to the business tested it, it goes into production. We do the quest, the branch runs all the tests. Some of them may fail because the system analyst may not have taken into account everything. Then review happens. Once preview is over, it goes into the production. You don't have to do anything else. You basically have a product pipeline with which you don't have to do anything. Okay, now when we have a new product, we have to develop it for about a month and a half. I think this is quite decent. Since we're building new data platforms all the time, We don't have everything in there that is in our warehouse. Whereas we have a lot of products, right? We're talking about production right away. We have lots of things on the storefront. The challenge is we have to maintain Iceberg. We have to clean CI and the user schemes because we give some level of freedom to our users. Sometimes we have to manually work with full refresh. Yep, and sometimes it can break some things, but that's okay, we fix it. If we don't do maintenance, if we don't do any of it, you'll be in trouble. Your budget will go out of proportions, everything will break down. Maintenance on the data platform, I think, is much more important than bringing in additional functions. Since we live in the Yandex cloud, we of course have to count money. Okay, not to go bankrupt, we have to use the elasticity of the system. You have to know your infrastructure. You have to understand when it works well, when it works less well, not when the jobs are dropping. So use the specifics of your Airflow, like Airflow 3, which is quite scalable. And you can use the Yandex cloud peculiarities. For instance, if you use the instance during the nighttime, it's 3 times cheaper. And SLA for data storage is not the same as the services, right? So you don't need the geo distribution. You can probably live in the same region and do with the smaller installations of clusters. Now, you have to understand that there is a certain process that you look at, and you understand what is good and what is not. For example, look whether you are using additional disks. If this is indeed the case, this is too bad because you are paying for them in the cloud, for the cloud usage. And so basically, initially, when I looked at what we're using, there were lots of disks that we were not using. I deleted them. We started saving 3,000 rubles per day. You see, the Yandex services, just any other cloud, like to give you many options that you don't really need. You have to streamline your configuration. You don't have to have 3 sharded clearhouse. Okay, sometimes you need just one if it works well. So clearhouse is the database for engineers, and sometimes all of your clearhouse lives in one replica and nothing stays in the second replica. Why? Because the users don't work well with replicas. The results. So basically, we started saving about 50% once we looked at what could be changed without changing the things drastically. We just optimized the configuration. In a sense, the cloud makes you do that. If you neglect it, you pay more. All right. I mean, it's not your money. You have your own work, you have your own job, but I don't have to go up to the top floor and defend our budget, right? That's why we were able to build a new platform within the existing budget. Thank you very much. These are my contact info. For the feedback, for the contacts, please leave your feedback. Hopefully, if my presentation is the best, I'll get a bonus. But I only have about 6 minutes for questions. So basically, bottom line, maintenance, platform building is a process, just as in production. You look at the conveyor, you see what's going on, you see your data, you decide to introduce changes. and then you evaluate whether you're able to make it better or not. If not, bring it back. If not, keep looking, keep experimenting. If you think that once you've done it, everything will work automatically, no, it will not. Maybe it will work even worse. So basically, work on your culture. Culture, I think, is more important than the skills. Thank you very much. Oh, Dmitry, thank you. Thank you. We have a Q&A session very quickly. Last time we forgot to give the prize for the best question, but we will do it now. Okay, so we have a small gift small award for the good question.
Слышно?
Да, да, да.
Can you hear me?
Ты
Yeah.
сказал, что у вас есть создание
All right. You mentioned
А
that
скажи,
you have
как решаете
sample
проблему
creation
консистентности сэмплов,
function.
или вам пофигу?
How do you resolve the issue of samples consistency? What do you mean by
То есть,
that?
смотри, вот ты
We go to
тащишь
Trino, there is a SQL
несколько,
function. Okay, so you bring,
сетов, несколько
you take Mongo, you take
Как
several
ты
data set, several documents from Mongo.
То есть забиваешь, да?
How do you,
Ну, то есть у вас нет этой проблемы.
what do you do with the related data? Well, we don't have a task like this. In Trino doesn't have this problem. It's not that. It's that our task is to check the major kind of the amount of errors. It is not our task to see whether a column was lost or not. It was a fast win, which we did, right?
Тут уже связанность данных проверяется DBT тестом.
And the data connectivity here is checked by the DBT tests. This is a separate process about the data integrity check. Thank you very much. Any other questions? Okay, you mentioned that you are using Iceberg and Flink. Flink? No, I didn't say we were using Flink. Well, but some kind of processing, right? You use Iceberg and cold storage, and during processing, sometimes you have to bring up the data. Do you go to Iceberg or do you have hot storage in order to speed the things up? At the time, we don't have the hot storage. We have Iceberg tables. We have real-time dashbot, which we are piloting right now. So everything is written into Iceberg right now, and then later on, Trino aggregates that and brings it over to the superset. So we have maybe 2 or 3 minutes lag. Do you have ClickHouse? We don't. Yes, we do have ClickHouse. So right now we are determining its future fate. There was an attempt. Okay. Okay. I don't. What's going on? Your mic is not working. Oh, I see. I probably pressed a button. Could you please turn on my mic? Turn my mic on. Give it to me. Okay. Hi.
Да, у нас мы
All right. So once again,
то, как мы используем ClickHouse.
yeah, we are rethinking the ClickHouse use right now. The ClickHouse will be the hot layer, absolutely.
Есть горячий слой, но просто на нем есть
It is a hot layer right now, but we're using the old version right now, and we are. What about Cassandra, or is Cassandra too old? No. We don't have that many, that much volume, so one instance is certainly enough. If we talk about Cassandra, these are the products which should bring company money or resolve a common task. Again, our specifics is that we are a middle-sized company, so we can build such a wonderful, elegant system on Trino, based on Trino, and it will work well, I think. And I think we can do not T-1, but T-hour. And then again, and the business has a need for several seconds lags. We know how to put this together. We have a very good team of engineers, and we can probably organize it on different stacks. Okay. Any other questions? Can please talk into the mic.
Ага. Ты рассказывал про то, что в CI вы поднимаете мини-версию хранилища. Подскажи.
You said that in the ICI you're able to look at the
Мини-версию хранилища занимает это 5-10 минут.
the mini version of the storage. How long does it take? It takes about 10 minutes because we use assembler. We use the same infrastructure. In the future, we will have several clusters of Trino. It needs resources. Right now, it lives in Trino and it feels okay. But we basically will be covering it with the same click, with one. Yeah, and behind it there will be several clusters. But referring to questions about 5-10 minutes. So using prods, but you're creating another mini version. Yeah, since the superset tables are sort of represented at the golden storefronts. This takes, yeah, we do it on prod info. We have testing quad on Trino. We haven't used it so far. In the future, we will use the CI cluster.
Можно нарисовать очень крутую инфраструктуру, архитектуру.
We don't want to overspend. You can draw a beautiful architecture, but it will be too expensive, and it won't work, or will work worse. But you are using Iceberg. Why would you need a sample? Why don't you make a different branch? If the costs for storage are higher, if you use the Iceberg. We have an old Hive. I'm not so sure that we can use snapshots. And probably it is also about the balance. So we are looking at how much we spend on the storage and how much on engineers. A small question. Before you said that you have a system analysts that they do common fronts and work with data. We call this profession the data platform, and the head of system analysis has a somewhat different outlook, and these are the people who can do SQL and don't move outside Kavan. And the system analytics is the DWS, and it takes people with certain skills. And these are the people of the future, data engineers. And so they are data engineers. The data engineers build the platform. There shouldn't be too many of them, so that through their suffering they would give birth to beautiful architecture. And you said that the maintenance of spreadsheets is important. How do you automate the process? The maintenance of spreadsheets is done in the following way. We have ducts that launch the delete of files. They clean up the personal schemes, and Java comes to your personal scheme, and it deletes everything. And people know that it is just for daily work. So we write ducts. All the spreadsheets, you have the ducts that clean all the spreadsheets. The Trino has this whole functionality, and all we have to do is to launch as SQL code for all the spreadsheets, and it works beautifully every day, and some maintenance is done on this. This is fast. It doesn't take a lot of time. You have to think about this and do it. Okay, choose a victim. Who are you going to give? Where is this goal that asked about system analysis? Because it is her pain. Give her. Are there any people who asked questions before? Okay, so Bronislava is getting book. And please write something. And otherwise, Dima will tell me that I was simply the best. So write your honest feedback.